Over the edge. Horizontal projectiles. So here's a red ball rolling off the edge of a table, a fairly typical horizontal projectile problem. What does its path look like as it falls? Well, if you recall from our ground launch, it's going to be a parabolic path. But now it's just half of the parabola. It starts horizontally and then falls with that parabolic shape. Let's try a different problem. What if at the same time we rolled the red ball off the edge of the table, a green ball was dropped from rest from the same height at the same time? Which would hit the ground first? Believe it or not, they both hit at the same time. Exactly the same time. Even though one has horizontal velocity, neither one of them has any vertical velocity. The horizontal ball has some horizontal velocity, but it doesn't have vertical velocity. Green ball doesn't have velocity in either direction. It's at rest. And so VIY and VIX are 0. Since both have VIY 0, the time to fall is simply dictated by the acceleration due to gravity. So we deal with these problems by handling one dimension at a time. Both balls begin with no vertical velocity. They both fall the same distance vertically. How do you find the time for fall? Well, we go back to our kinematics equations. And then we use the time for the horizontal part of the problem. So, we use our displacement equation to help us find the time. Let's try this one. A bullet is fired horizontally from a gun that is 1.7 meters above the ground with a vertical velocity, with a horizontal velocity of 55 meters per second, I apologize. At the same time that the bullet is fired, a shooter drops an identical bullet from the same height. Which bullet hits the ground first? Believe it or not, they hit at the same time. And what else can we find out? Well, we can find out how far away the horizontal bullet traveled. The time we get from the vertical. It's going to fall 1.7 meters, so VIY is 0, plus 1 half negative 9.81 meters per second squared times t squared. From that, to fall 1.7 meters takes 0.59 seconds. We could use that time in the horizontal to figure out exactly how far we travel. In 0.59 seconds at 55 meters per second, we'll travel 32.45 meters. Here's another problem. Typical, an airplane is making a supply drop to troops behind enemy lines, is flying with a speed of 300 meters per second at an altitude of 300 meters. How far from the drop zone should the aircraft drop the supplies? We get the time from the vertical. Remember, time is always going to be the vertical problem. Falling 300 meters towards the Earth, we get a time t equals 7.82 seconds. Once we have that time, we can use that time to figure out the displacement in the x, in this case, 2346 meters. How about this one? This is a stunt pilot, stunt guy, jumping off of a building onto an air mattress that's been placed at the edge of the building on the street, 15 meters below the edge of the building. What minimum initial horizontal velocity does he need in order to make it onto the air mattress? Well, again, we use the vertical to find the time. It's going to take him 3.03 seconds to hit the ground. So, knowing he has to travel 15 meters horizontally, we can use v equals d over t to figure out that he needs to be traveling horizontally at 4.95 meters per second. Finally, here's a CSI for those CSI fans. CSI detective investigating an accident scene finds a car that's flown off the edge of a cliff. The car is 79 meters from the edge of the 25-meter high cliff. What was the car's initial horizontal velocity as it went off the cliff? Believe it or not, crime scene investigators, these forensic guys, use their physics to help them. So if we know it had to fall 25 meters, we use that to find the time. It was falling for 2.26 seconds. And therefore, if it traveled 79 meters in that 2.26 seconds, it must have been traveling horizontally at 34.96 meters per second when it left the cliff. So you can see how we can use our knowledge of physics to determine things like how far an object lands off the edge of a cliff, all kinds of things. Anyway, on to the next one.